Hello everyone, Olga show for you. We are back in Santa Clara Convention Center here June 25th, 2013. We are PCI SIG conference here with Agilent Technologies and we have Rick Eads with us. Tell us, what do you do for the company?
I work for our oscilloscopes products group. We make products like our 90,000 series oscilloscope. I'm also the PCI Express program manager for the company, which means that I'm responsible for all of the solutions that we have within the Agilent portfolio of products that support PCI Express.
Okay. And what brought you to PCI SIG conference this year?
Well, a couple of things. First, I serve on the PCI SIG board of directors, so we have an annual members meeting that we kick off the conference with. Prior to that, we have a board meeting that finishes out the third quarter of the year for us. So we had our board meeting on Monday, and then we have the conference started yesterday. So that's one reason why I came. The second one is we had two members of Agilent Technologies that gave papers in the conference, so they're participating in the conference. So I wanted to make sure I was able to see the papers that they presented. And then the third part is the demo. So we wanted to have a booth here to demonstrate the products that we have for support of PCI Express as a technology.
How long do you work for the company?
Long time.
Long time.
Right out of college, so it's been.
Wow, okay. So, and to be in your position, what's your education? As you mentioned, the college.
Yeah, so I got my undergraduate degree in electrical engineering, like many electrical engineers do, and then I have a business degree as well.
So for many years, you not only with Agilent Technologies, but you worked with board directors of the PCI SIG conference?
Right, so it's kind of a dual role. So the PCI SIG is a nonprofit company.
Right.
And it consists of about 780 member companies. But we operate it as a nonprofit corporation. So the membership votes every year for 9 directors to serve on the board of directors of the nonprofit. So it's a volunteer role. I don't get paid for it. But I do represent our company on the board of directors, and we provide direction to the activities of the SIG. So we organize the developers conferences. We do one here. I did a paper in one that we just did in March in Israel, for example. So we move them around. I also participate in workshops, so that's a big activity set that the PCI SIG does, where we hold workshops where member companies can bring products, and we'll use these tools to actually test them.
And I believe like you support maybe IEEE conferences or members, a lot
this
of
is
things
somewhat
happening.
separate of the IEEE.
Yeah.
We certainly have folks that interact with the IEEE, but the PCI SIG is really focused on PCI Express technology, whereas the IEEE has a very, very broad footprint on the technologies that it covers.
All right, so Agilent Technologies also help a lot of engineers, I guess, to collaborate, communicate, and network as well.
Sure. I mean, the company was founded by Hewlett Packard Company and then split from Hewlett Packard in 1999. I mean, if you look around us, we're in Silicon Valley, right?
Right.
So in 1938, when Hewlett Packard started, this was all farms. So Hewlett Packard was the first high technology company in Silicon Valley, founded Silicon Valley. Agilent Technologies is representative of the businesses that Hewlett Packard started, which is instrumentation for electrical engineers.
So talking about testing, because when you create, like Hewlett Packard company, create their own equipment and being one of the leaders in the industry, they needed to have testing equipment. That's how it's kind of moved into testing, or they always had that to have oscilloscopes?
Sure. I mean, when engineers are working with electronics technologies, it's with electricity, electronics, semiconductors, and the like. And it's necessary to have instrumentation that will provide visibility into the functionality of the designs that they're working on. So if you're trying to observe electrical behavior that's occurring between two different types of electronic instruments or electronic devices, it's difficult to see electricity, right? But we have ways of showing that, of generating electrical signals, and essentially providing a test platform for making sure that products are working as advertised or working as their designers intended.
And what's your new solutions for this? You said you have 2 new products or solutions you brought for this conference?
Well, we had 2 papers that we're doing, but we do have a number of products that we brought to the conference to show solution sets for PCI Express. Like for example, what we have here is a receiver test solution that's designed to support PCI Express Gen 1, Gen 2, and especially PCI Express Gen 3. The demo consists of the primary product, which is a bit error rate tester. This product generates a signal that is fed into our device under test, or DUT, and it stresses that signal to the point where the product may have difficulty actually recognizing that signal. We send a certain pattern to the device, and then the device retransmits it back to the instrument. The instrument compares the signal it sent with the one that it's receiving from the DUT and tries to ensure that those signals are identical. That's why it's calling it a bit error rate tester. It's testing to see that what it's given is exactly what it's sending out.
So you make this hardware and also software?
That's right. We make the hardware. We also have software that helps to facilitate control of the entire test setup. As you can see, this is coupled to an oscilloscope as well. In order to generate this test signal, it has to be calibrated very precisely. So the software that we write controls the oscilloscope and the bit error rate tester to drive a signal with certain requirements that are precisely calibrated using the oscilloscope before the test actually begins. So you have software tools, you have an oscilloscope to analyze signals, you have a generator that generates those signals along with signals.
All right. So what is the other equipment we see on the other side of the table here?
Sure. This one was receiver test. The one that you're looking at right now is transmit test. So what we're showing with our transmit test solution is tied directly in with one of the papers that one of our engineers is giving at the
I think so. Like if we can hear you, get better. All right.
pull that down. There. Okay, so with PCI Express you have many lanes that you're testing. You also have different speeds that you want to analyze for the devices and the signals that they're generating. For example, PCI Express started out at 2.5 gigabits per second. We went to our next generation called Gen 2, which was 5 gigabits per second. And now we're testing the third generation, which we refer to as Gen 3, which is 8 gigabits per second. So if we want to test...
I know already people talking about Generation 4.
Generation 4 is on the docket. That'll probably show up in maybe the 2015, 2016 timeframe.
How many was the speed?
It'll be 16.
16, okay.
So we went to 2.5 to 5 to 8, and then the next generation will be 16.
So it's like doubling all the time?
Yes,
okay.
That's the goal, is to increase, every time we wanted to double the throughput of the technology. So every time we add more speed, we increase the complexity of the testing. And right now, with each of the lanes, and a lane is one pair of differential transmit and receive lanes, you can have up to 16. For each one of those 16 test points that we might want to test, there are 14 different signal levels that have to be tested.
Oh, at the same time?
No, sequentially.
Okay.
But you've got 16 times 14, so that's all the different test cases. If you want to do a full validation, it's quite a bit of work. So what we've done here is to present a technique for automating the process of selecting each of those test points. So what we have is a generator that generates what we refer to as a compliance toggle pulse. And the pulse that is generated under software control simply takes the device under test, or our product that we're trying to test, and moves it through each of those 14 compliance states. Now normally you would have to do that manually by pressing this little button. I won't go into the details, but suffice to say that with this product, I can use software to control the generator to actually automatically go through and sequence through each of those 14 stages, and then I can move the cables to the next lane and proceed to capture data for the next lane that we want to test. So this is a way to facilitate automation of a complex test procedure and allow us to automatically capture data and stimulate the device we're testing to move it into each of the compliance modes that have to be validated.
So when we talk about different generations, would it increase speed of our computers, mobile devices? What's so important to look into Gen 3 and Gen 4?
Yeah, that's a really good question. So if you look at things like mobile devices,
Right.
iPhone. An iPhone is a pretty powerful little computer. It has memory, it has a user interface. But the real value of the iPhone isn't necessarily what's in the iPhone itself, right? It's the fact that as a smartphone, it connects to the World Wide Web, right? It connects to everything that's out there. So if you had no interconnect, or if there were no servers, no World Wide Web to connect to, you'd have a nice,
For the camera, maybe.
for the camera, for the music, you basically have an iPod, right? With a little bit of memory. But since we have a connection now to the internet, we are seeing a tremendous amount of growth in servers and services that exist in the cloud computing space.
Like big data problems.
Big data problems. You know, you have mapping software. You have lots of applications that are developing on the mobile platform that rely significantly on the back end. There's tremendous amount of growth in the number of servers and the deployment of servers. Companies like Google, companies like Salesforce.com, a whole bunch of different vendors that are taking advantage of cloud computing, software as a service, infrastructure as a service, platform as a service. All of those things are enabling a huge growth in mobile operators. Intel has said that for every 10 iPhones that get sold, they sell one new server. So for them, mobile computing is very important because it represents an opportunity, but also they're making money on it right now because they're actually selling a lot of chips and hardware into the server side, which is what's building up cloud computing.
Right.
So that is driving speed, and PCI Express Gen 4 enables a whole different approach to architecture because it enables solid-state storage drives, which helps to increase the responsiveness of the mobile applications. That's a good deal for us.
Yeah, everybody is getting a good deal out of it.
Right.
And you guys do good work here, so we don't have to worry about details in that phone. And all of this testing.
You don't have to worry about the details, right? You can just
Yeah.
play Candy Crush.
And then check my emails and be sure that I'm on alert, do my interviews, and have my pictures able to access to the computer right away.
You don't need to know anything that goes on behind the curtain.
I'm just interested. That's why I do it, because I'm like, how that was created and what's behind and what do you expect.
So let's talk about what we have in this demo platform. Simply stated, this is our PCI Express protocol analyzer and protocol exercise. So if I could, the two previous stations, the transmit and receive test, really had to do with what we refer to as physical layer tests. We're actually testing the physical characteristics of the transmitter. But ultimately, those devices have to transmit data. You have to be able to store data, you have to be able to move data from one point to the next. To do that, we have to encapsulate the data in what's referred to as a transmission protocol. So it's a higher level of abstraction of the operation of computer systems.
Right.
You can think of it as, the physical layer is like when your phone rings, right? You hear, phone rings, somebody wants to talk to me. You don't know what they want to say or anything like that, but you have to answer the phone, right? So you answer the phone, that's really the physical layer getting established. You don't really care how they're going to connect to you, but you want to know that they're going to connect. Right. So you say hello, and then the other person says hello, you identify one another. Right. So that's all protocol. The same thing has to happen with computers. What we were talked to previously was all about connection of the physical layer to the ringing of the phone analogy, all the way to the point where that communication link is established. Then this is where the data has to be transferred. Right. And so there's a very specific protocol for how data is transferred. If there's an error in communication, how that data is retransmitted. There's communication about how the packets the data packets are transferred, how much data is going to be transferred, so that there's a very accurate way of conveying data from one location to the next.
And then because data could be encrypted as well.
Data could be encrypted, the data can be encoded with different encoding schemes for each different generation. So this allows us to look at the data in the context of the protocol or the packets as they're being transmitted. So that's what the protocol analyzer is for. It helps us to understand whether we have a system that's capable of honoring the very complicated PCI Express protocol.
All right.
Okay.
Oops, and we have another one.
Yeah, and then the last one, this is interesting solution set.
Looks like a software only.
Yeah, so you've got up here what we call our Advanced Design System, or ADS. And primarily this is really used for when somebody is designing a physical layer IC, right, or integrated circuit. It's got to go into a package. They want to make sure that the package, the operation, the physical performance of that package at high speeds is going to meet the transmission line characteristics that are necessary. We also have a physical layer test system. For PCI Express, we talked about transmitter and receiver, but another big component of PCI Express, especially at high speeds, is the channel. And there are rigid specifications on how the actual wires, if you will, need to be connected between two PCI Express devices. There are physical characteristics that are necessary, that have to be met in order to ensure that it's going to be capable of operating at 8 bits per second. So our physical layer test system and ADS software help us to simulate packages, transmission lines. They work in concert with physical layer analysis, which is called vector network analyzers that extract physical frequency-dependent performance characteristics of data transmission.
I'm wondering how many people at Agilent roughly?
Roughly about 19,000 or something.
19,000. So you're not only in Santa Clara location, because it's only a few buildings there. It's
Correct.
all over the world.
All over the world. We have R&D sites and factory divisions and sales office in almost every country in the world that's invested in technology. And a very global company. Over half of our sales come from outside the United States.
So no wonder we see you almost at every high-tech conferences. So you're like, oh, Agilent Technologies, of course we know them as probably another solution, another device.
Yeah, absolutely.
So that's very good. And what would you wish for our viewers of today's show?
Well, keep in mind that PCI Express is a very popular, ubiquitous technology in computing. We're going to move it into the mobile space. And Agilent, as a tools provider and as a member of the PCI SIG Board of Directors, we're very invested in PCI Express technology. I believe we have the broadest portfolio of tools for folks that are engaged in PCI Express design and development. So if you're looking at PCI Express, or you're thinking that you might want to develop a product that uses PCI Express technology, please consider Agilent Technologies as a provider of the solutions that you need to meet your engineering tasks.
And of course, I always admire volunteers and also admire engineers who makes our life easier with all of the things behind the scenes happening, definitely moving our world for a better place to live, I hope. Yeah. And be healthy, happy, and be able to reach and communicate with many people in terms of all of the products we use in this world. Okay, thank you. That was Olga show from you to you and part of Tech World and Tech Evolution. Thank you. Bye. And thank you.